Series by Isabel Calderon. Okay, so first of all, what is a series? A series is the sum of an arithmetic sequence. Okay, so as we can see here, I have like this little chart, and what this means is like what there's a certain formula for each of these. So an arithmetic sequence, a geometric sequence, an arithmetic finite series, arithmetic infinite series, I don't know how to say it, or geometric finite series, and so on. Okay? So this is just like a quick little summary of what's going to happen. But I'm going to explain everything. Alright, so first what I'm going to talk about is Carl Gauss's, or I don't know how to pronounce his name, is the problem he found, like he solved in a small, like a short amount of time. And what the problem is add all the integers between 1 to 100. And so technically what happened is that, so you have to add them all up. And so what he figured out is that if he writes it out, and if you write it backwards, and then if you add both of these series together, you're going to find out that if you add 1 plus 100 is 101, 99 plus 2 is 101, and so on. And then he found out there's 50 pairs of that. So now that we know that, we can say that there are 50 pairs that add up to 101. Therefore, we can conclude that the answer is 50 times 101, which is equal to 5,050. Okay. So the first one we're going to learn about is the arithmetic series, and the formula is of S of n is equal to a1 plus an times n divided by 2. And as we can see here, that this is what each of these mean, or what they're asking for. So so S is sum of arithmetic series, so that's like the amount of, that's like the amount, or like how many terms there is in the whole series. And so as we can see, a1 is the first term, an is the term and the nth value, and then n equals the number of terms. And here's an example of an arithmetic series. Okay, so let's try an easy problem. So first we're going to see that, so it's negative 32 plus negative 34 plus negative 36 plus as many as terms, and then negative 778 plus negative 780. And as we can see that we can already right off the bat see that the common difference is we're subtracting by 2 each time. Okay, so first we need to find out what we need for the formula. And so what we know is what a1 equals is negative 32, and the last term is negative 780. And so to find out how many terms there is in total in the whole series, we're gonna find out we're gonna have to subtract both from each other. And so that we're gonna get negative 748, but we have to divide it by negative 2 because that's a common difference. And so we get 374. But that's not the number of terms there is in total in the whole series, because we still count the first term. Okay, so we just add one more, which is 375. So now that we know that n is equal to 375, because that's the total of terms there is in the series. So now that we know that, all our information we can plug into our equation, which then equals this right here. So this is the total. This is the total number, terms in the series. A1, an divided by 2, and then times n, because that's, like I said, that's the number of terms in the whole series. And then once we just solve it, we're going to get negative 152,250. Okay, so now we're going to try a harder problem. So what we know here is that a2 is equal to 4 times a5. So it's 4 times bigger than that. And so we don't know what a1, and then we know that S of 10 is equal to negative 20, and then also we don't know the common difference. So to find this out, we're going to have to use this formula because we're just going to have to plug in and try to find each term that we need. And so this is the force formula we're going to use. And as we know, so we're going to do this, okay? So we're going to do A1 plus D is equal to 4 times A1 plus 4D. Because if we plug in what we know in our information into this is what we end up with. And so now we're just going to distribute 4 all the way through this, and we're going to end up with A1 plus D is equal to 4A1 plus 16D. And so if we add A1 over to 4A1, we're gonna if we subtract, we're gonna get 3A1, and then if we subtract D from this side over here, we're gonna get 15D. So pretty much we're setting it equal to 0 because we don't have any terms left on this side, on the left side. So then we're just gonna subtract negative. We're gonna subtract 3A1, which is gonna equal to negative 3A1, which is equal to 15D, and then we're gonna end up with A1 equaling negative 5D. Okay, so now we're gonna plug it into our new formula to find out our other information. So now so we know that S of 10 is equal to negative 20, so we're going to plug in negative 20 is equal to, so N is going to equal 10. Is going to equal 10. Okay? And so we're going to divide, so we're going to do negative 20 is equal to 10 divided by 2 times 2A1 plus 9D, because we know that once we do 10, we're going to subtract it by 1 and get 90. And so now we're just going to keep going. So we're going to do negative 20 is equal to 5 times 2A plus 9D. So we're going to distribute 5 and get this. And then as we did last time, we know that A1 is equal to negative 5D. So we're going to plug in negative 5D and we're going to end up with this right here. And so we're just going to multiply 10 times negative 5D, which is equal to negative 15D. And so the equation we end up with is negative 20 is equal to negative 50D plus 45D. And since we can add these two together, we're going to end up with negative 20 is equal to 5D. And so now we know the common difference is D. The common difference is 4. Alright, so now that we know this information, we're going to say that negative 20 is A1, okay? And so now that we know that the common difference is adding 4, we're gonna do negative 20 plus 4 is 16, and then so on, okay? And so as we said here, that 4 is, A2 is 4 times bigger than A5. And so we go, alright, so A2 is right here, so that's A2. And then we're going to go do 5, so it's 2, 3, 4, 5. Is that true? Yes, that is true. And so we also found out that, we also need to find out that if we add all these together, we're going to end up with negative 20. So if we do that, we're going to cancel this out, which is 0. We're going to cancel the 12s out, which is 0. We're going to cancel the 8s out, which is 0. And then we're going to cancel the 4s because it's 0. And then we're just going to end up with negative 20 plus 0, which is equal to negative 20, which is what we said, which is true. So so after doing all this, we used two equations to find each information we needed, and we found out that that is true. Okay, so next. So to prove that in an arithmetic series, how to prove it is we're going to use two formulas. There is a U1 is equal to A plus N minus 1 times D, and then that's to find the nth term. And so the second one is we're going to do S of n is equal to n divided by 2 times 2a plus n minus 1 times d, which is to find the summation, which is pretty much the summation when you add all the terms. And so what we need to do is derive the formula. So we're gonna derive it. So what I mean by that is we're going to say that A, that's A1, plus, which is, so then we're going to do A, and then it's going to, so that's the first, and that's the first term, okay, as we see right here. This is the second term, which is A plus D, third term, A plus 2D, and then the fourth term is A plus 3D. So, now that we know that, because that's pretty much explaining it, so so here it's to find the nth term, take one term away, and what I mean by that is right here. Okay, so that's pretty much what it means. Alright, so now we're going to use, so now we're going to prove it. Now we're going to prove that in arithmetic series. So now we're going to do S of n is equal to A plus A plus A plus D plus A plus 2D, and then the last term at the nth term is equal to A plus n minus 1 times D. Okay, so now that we know that, we are going to do S of n is equal to A times n minus 1 times D plus A plus 9n minus 2D plus A. Okay, so now that we know that, we're going to keep on going, and then we're going to add these two together, which is then equal to 2A, so we're going to do 2 S of n is equal to 2A plus n minus 1 times D plus A is equal to n minus 1 times D, and so on. So then we're going to keep on going, and so we're going to keep simplifying them. And so we're going to end up with our equation of an arithmetic series. And this 9 is a mistake, so ignore that. Okay, so don't pay attention to that. Don't ignore that. Scratch that out. So ignore that. Okay. Anyways, so now we found out. So now that's the proof of an arithmetic series, and that's our equation for an arithmetic series. Next, we're going to do finite geometric series. And so here's our formula, and then this is the same thing as last time. It's just explaining what each of these equal. And then here's an example of a finite geometric series. Alright, so let's try an easy problem first. Okay, so we have our equation here. And so this -4 is going to be our A1, because that's the number we start off with. 19 is how many terms there are in the finite geometric series, and then that's the term we start with. So now we need to plug in what we know into our equation. So we're going to do S of 19 is equal to -4, 1 minus -2 to the power of 20 divided by 1 minus 2. And then what we're going to end up with is S of 19 is equal to 1,398,100. Okay? Alright. Next one, which is going to be a harder problem, but not as bad. Okay, so as we know, as in this time, we know the same information here. And this is this right here is so finite. Okay, so we know that since so that's the same information we know. And so this right here is that, so there's 99 terms, right? Technically that is not true, because in this case there is 100 terms, okay? So we know that n is equal, and then so we know that A is equal to 2, so A1 is equal to 2, and then R is equal to 3. Okay? So now this is our formula, because we needed to derive it, because if not, then it wouldn't make sense. So this is our first term. And so we're going to keep on going on to 2 times 3 to the power of 99. Okay? So now that we know all our information, we're going to plug it in. So we're going to do S of 100 is equal to 2 times 1 minus 3 to the power of 100 times 1 minus 3. Okay? So then if we calculate that, that's your answer. Okay, next we're going to do sigma notation. So as in a few other problems, you've noticed this, but it's just another way of saying find the sum of. And then this is what it means. So this is the value of n. Okay, we all know this information. This is this is what it is. Okay, so first, our easy problem is we're going to find out what. So we're going to find out what. So we just want to find the first term in this case. Okay, so we're going to do n plus 6, and then we're going to do is equal to 0 plus 6 plus 1 plus 6 is equal to 6 plus 7 equals 13 because we plugged in because we wanted to find out the first term, so that's that. And so when we added it, our answer is our answer is 13. Okay, so now we're going to try a harder problem. So this might seem a little scary, but it's not as bad. Okay, so it's just going to be the same thing as the easy problem. So we're going to do, so this is it just written out. So this is just because we want to find the second term, so it's just written out for us. Okay, all this right here. So once we start figuring it out, we're going to know that it's going to be equal to 5 plus the square root of 1, because 4 times 0 is just 1, plus 5 plus the square root of 4, because 4 to the power 1 is just 4, and then we're going to do plus 5 plus 16, because 4 to the power 2 is just 16. And now we're just going to go on, and so we're just going to do 5 plus 1, because that's the what it equals, and we're going to do plus 5 plus 2, because if the square root of 4 is equal to 2, plus 5 plus 4, because that's the square root of 16, so that's 4. And so now if we add 6 plus 7 plus 9, we're going to get 22. And that's our answer. Alright, infinite, or I don't know how to pronounce this. I might be wrong, might be right, I don't know. Geometric series. And so this is our formula right here. Okay? And then this is an example of if we plug in numbers or something, right? And so an important thing to notice about infinite geometric series is that first we need to find out whether the geometric series sums to specific value converges or sums to a positive or negative infinity diverges. Then if the series converges, we'll compute it using the formula. Because if we don't, then it's not going to make sense, because if the value is because if the value is positive or negative, because we need r to equal bigger. We need the common ratio to be bigger than 1. And if that's not the case, then that means that we can go further on using the formula. Okay, so knowing that, we're going to do an easy problem. So what we're going to do is we have our formula here, okay? And so S is going to equal to 9, because that's our first term, divided by 1 minus 0.8. Okay? So then that's just going to equal 5, because once we plugged in our information, that's just what it equals. Okay? So our harder problem is, this is not as big of a harder problem, but okay, so we have this right here, and so we know that the common ratio is times 1/3 times 1/3. And so now that if we write it out, this is what it's going to equal, and then if we put in sigma notation, this is what it's going to equal. And so if we plug in all our information, like A1 and then the common ratio and that into our formula, we're going to get 8 divided by 1 minus 1 divided by 3 is equal to 8 divided by 8 over 3 is equal to 8 times 3 over 2, which is equal to 12, and that's our answer. And that's it. And thank you for watching.